You tap send on a WhatsApp message. A photo, a joke, maybe just a quick hello. To you, it's instant. It feels almost like magic, right? But what's really happening behind the scenes is this incredibly complex, elegant dance of technology. Today, we're going to pull back the curtain and see exactly how WhatsApp's architecture makes it all work.
And to really get it, you have to start with the scale. The sheer scale of it all. WhatsApp serves over 2 billion active users. Let that sink in. That's more than a quarter of the entire planet, all connected through one single app. And yeah, those users are busy. Every single day, WhatsApp handles over 100 billion messages. But here's the part that's truly mind-blowing. During its biggest growth phase, this entire massive system was built and run by a team of less than 50 engineers. Just wow. So that brings us to the big question, right? How is that even possible? What kind of technology, what kind of architectural philosophy lets a team that small support a communication network for the entire globe? To figure it out, we're going to follow the journey of just one message. We'll start with the core philosophy, then look at the tech that handles all the connections. We'll see how messages get encoded, track their path through the servers, unravel the puzzle of group encryption, and finally, look at the next big challenge for private messaging. Let's get into it. So the first thing you have to wrap your head around is this fundamental paradox. You see, most social networks are built to be these giant data warehouses. They collect and store everything you do. But WhatsApp, it was built to be the exact opposite. It's a high-speed router. Its main job isn't to keep data, it's to move data. And they do this using a model called store and forward. Now the key word here is ephemeral. It means temporary. The server's role is fleeting. It holds onto your message for the shortest possible time, just long enough to make sure it's delivered. And then poof, it's gone. The permanent home for your chat history is on your device, not theirs.
Okay, so if the server's job is just to route billions of messages, it needs to handle millions of people connected all at the same time. The secret weapon that makes this possible is a programming language that, funnily enough, has its roots in the old-school telephone industry, Erlang.
And this is where Erlang's genius just completely shines. A traditional server uses a ton of memory for every single connection, which limits it to maybe a few thousand people at a time. But WhatsApp uses something called the actor model. You can think of it like having millions of tiny, independent workers. Each connection uses a minuscule amount of memory, which means a single server can handle over 2 million connections at once. And get this, if one of those little workers crashes, it doesn't affect anyone else. The whole system just keeps on chugging. It's incredibly resilient. Okay, so we've got a system that can handle millions of connections. Awesome. But what about the messages themselves? Remember, a lot of people are using this on slow, unreliable mobile networks. So how do you make those messages as small and as fast as possible?
Well, WhatsApp basically created their own dialect of a standard protocol, and they called it FunXMPP. Instead of sending long, wordy text tags like message, they just convert them into a single byte token, like 0x01. It sounds simple, but this one trick saves a massive amount of data on every single message, which is an absolute game changer on slow connections.
And even before that tiny message gets sent, your phone has to set up a secure channel with the server. For this, they use a protocol called noise pipes, and it is built for one thing: speed. It creates that secure encrypted connection in a single round trip between your phone and the server. That's a huge part of why the app feels so snappy and instantaneous. So now your message, which is this tiny, efficient binary package, has left your phone. It arrives at WhatsApp servers, which you can imagine as this virtual Grand Central Station. And this is where that store and forward idea we talked about really springs into action. Now, we've all obsessed over those little check marks, but what do they actually mean? Well, each one is a little status update on your message's journey. One gray check means your message has successfully reached the server. 2 gray checks mean it's been delivered to your friend's phone. And, of course, the 2 blue checks mean your friend has actually opened the chat and seen it.
And here's where that privacy-first philosophy really becomes real. The exact moment the server gets confirmation that your message was delivered, the instant you see that second gray check, your message is immediately and permanently wiped from the server's memory. It only existed there for maybe a few milliseconds.
But here's the thing. All of this communication is happening in secret, and that brings us to the absolute core of WhatsApp's promise, end-to-end encryption. But how on earth does that work, especially when you're in a massive group chat?
At the heart of it all is something called the double ratchet algorithm. Now, the easiest way to think about it is this.
Imagine a door with a lock and a password. With every single message you send or receive, that lock and that password automatically change. This provides something called forward secrecy, which basically means that even if a hacker managed to steal today's key, they couldn't go back and read yesterday's messages. It's an incredibly powerful layer of security.
And what this all means is something pretty profound. Since the keys to unlock the messages only exist on your phone and your friend's phone, the message that passes through WhatsApp servers is just unreadable garbage. It's an opaque blob of data. Even if they were forced to, even if they wanted to, they literally cannot read your messages.
But okay, what about a group chat with, say, 200 people? Encrypting that same message 200 different times would be way too slow and inefficient. So the solution is something called the sender key protocol. Your phone generates one single key just for that message. Then it encrypts only that key for each person in the group. The actual message itself is only encrypted once and then sent to everyone. It is such a brilliantly simple fix for a really complex problem.
But you know, this powerful encryption creates a really difficult new challenge. If nobody, not even WhatsApp, can see the content of messages, how do you deal with things like abuse, spam, and all the other harmful content on the platform?
Well, the answer is another clever system, and it's called message franking. The best way to think of it is like a digital postmark. As your encrypted message flies through the server attaches a secret, unforgeable cryptographic tag to it, a franking tag. You can't see it, you can't fake it, but it's there. So, how does this actually work when you report someone? Let's say you get an abusive message. When you hit report, your phone sends two things to WhatsApp's moderation team, the decrypted message you're reporting and that invisible franking tag it came with. The team can then use the tag to prove that the message is real and that it came from the person you say it did, all without ever having to read any of your other private conversations. It lets them take action on abuse while still respecting everyone's privacy.
And all this amazing technology, it leads to one final crucial question that's honestly much bigger than just WhatsApp. In a world where truly private, end-to-end encrypted communication is the norm, how do we, as a society, strike the right balance between that fundamental right to privacy and the very real need for safety? It's a question we are all going to be grappling with for a long, long time.